All right, quick show of hands. Who of you in this room is a mobile app developer? Raise your hand. Wow, that's a lot. It's like 70% maybe. Cool. And raise your hands. Who of you uses third-party dependencies as part of their software? It doesn't have to be mobile. Raise your hand again. Should be everybody who writes code, hopefully. All right, so who of you includes closed source binaries in the applications again? Raise your hand. About half the room, maybe. And finally, who of you did security audits on those libraries? Raise your hands. Some hands, maybe 10. Cool. All right, I think we can all agree that using third-party libraries makes our lives as developers so much easier. Most things we do nowadays are not even possible without the use of other dependencies. So it's also not realistic to do a full security audit on every dependency you have, right? Especially if you're a small startup or small company. There's no way you can do that. So in this talk, I want to raise some awareness of how easy it is to hijack SDKs and what you can do by doing that. So I'm Felix Krause. I've been building iOS apps for about 8 years now, and I've recently founded Fastlane, a tool to automate the release process of iOS apps. And so Fastlane is an open source tool that allows you to do things like localized screenshots, upload binaries, all these things that you as a mobile developer usually have to do manually. So what I do nowadays is a new project we started. It's called Fastlane CI. And you don't have to read all of this, just a very quick overview. It's a mobile-focused, open-source CI system. So this is what I do day-to-day now at Google. But what I'm really excited about is that Fastlane CI is not only going to be open source, but it already is open source. So our team at Google, we built this project in the open together with the mobile community. So I'm really excited about this. We always welcome new contributors. So if you want to be part of our daily development cycle on building Fastlane CI, feel free to join here. We always welcome new contributors. So enough about my day job. In my free time, I like to look into security and privacy projects. And so today I want to talk about the risks of SDKs. And you've probably heard it a lot of times already. Be careful about what you bundle with your app, obviously, or your software application in general. So being an iOS developer at heart, I took a look at the iOS SDK landscape. But all the things I'm describing here are generally applicable for any kind of technology. So no matter if you're JavaScript or backend developers, you run into the same risks. So I took a look into the top most used iOS SDKs, and I was shocked that 31% of the top 50 SDKs are easy targets for simple network attacks. Like, these are not complex things, simple network attacks, and we're going to talk about this in a few minutes. And all of this without you noticing. So what's the worst thing that could happen if an attacker runs malicious code through an SDK as part of your application? Why is all of this such a big deal? Well, the problem is that if you bundle an SDK in your iOS application, it runs under the scope, the permission scope of your app. So everything is signed under your application and your developer name. So this SDK gets access to all the things your app has access to, including things like location data, encrypted iCloud data, keychain data, and the user's photo library. Again, this runs under your application's name because you bundle an SDK in your application. So I think it makes sense now that we should avoid having code being run through an SDK that's malicious. So let's step back a little bit on how all of this works and how we can actually abuse some of the basic security network features to insert malicious code. So I'm not a network expert. I'm not a security expert at all. Again, I'm an iOS developer. But I had this assumption that it shouldn't be hard to insert malicious code into an SDK. So what comes now is a very simplified view of how the network stack looks like. So again, this is a lot more detail actually in there. So most of you already know the difference between HTTP and HTTPS. So HTTP is unencrypted, right? Everybody in the network can look at each packet that goes through the network, and they can not only see these packets, but they can actually unwrap it and look at what's inside. And not only that, they can even replace content or add new content to those packets, and the receiver has no way of verifying that this didn't happen. With HTTPS, things are encrypted, meaning that other parties in your network can still see those packets, but they cannot open them. They cannot look inside. And most importantly, they cannot modify the content. So you as a receiver can always be sure that it didn't get modified on your way here. This works through the SSL handshake. So with HTTP, this doesn't only work through public Wi-Fis, but it also works through encrypted Wi-Fis and through Ethernet networks. So taking that information, how does your computer decide if it should use HTTP or HTTPS? Let's take a web browser. You enter google.at in your web browser. And so you see a screenshot of Charles' web proxy here. And your browser, again, this is simplified. It's not actually how it works nowadays. But your browser would send a request to Google saying, I want google.at. And Google is like, ha, HTTP, what do you have in? We need HTTPS. So it's going to send a response saying, 302 permanent redirect to HTTPS, google.com. So you might already see the problem here. The response now is also being sent through HTTP because you never did this initial SSL handshake. So what happens? Anybody in the network can now easily interfere this packet and replace the content to say, yeah, HTTP is fine. Let's just stay unencrypted. So this is called SSL stripping. And we're going to talk a lot more about this in a second. So remember those really exciting computer science classes about the OSI layer diagrams? So I didn't like them. I didn't know why we had them. But turns out they're really useful. There's a reason they exist. And most of you probably know the concept. I don't want to go into detail. But all you have to know is there are different layers. Each layer has their own responsibility. And one of the layers asks the following questions. Which MAC address belongs to the following IP address? And now any computer, any host in the network can reply with, that's me, that's me. And then the router will remember that and store it in an ARP table. The problem here is that the router has no way of verifying that this is actually a right response. So a malicious actor can now always raise their arm and say, that's me, that's me, that's me, and basically spams the whole caching table. And this is called ARP poisoning. So looking at the drawing above, this is how you communicate with the internet. Again, very simplified. You, as a developer, communicate through the router, through your internet service provider, with the internet. So how would it look like if an attacker now successfully does a man-in-the-middle attack while the attacker is in between? So every single packet goes through the attacker to the next host. Again, if it's HTTPS encrypted, they can only see some basic metadata. They can see, for example, the host and some other stuff. But they cannot see the content, and they cannot replace the content. So interestingly enough, you run into the same risk every single day because you trust your internet service provider. They are in the exact same position. And the same also applies to VPNs. If you use a VPN, they are basically doing a man-in-the-middle attack because they take your packets and forward them. And if these are not encrypted, they can do whatever they want. So again, this is nothing new. It's called a person-in-the-middle or man-in-the-middle attack. And you can read up on it. Nothing new. But how can we apply this to iOS projects and iOS SDKs? Most of you probably know that CocoaPods is the de facto standard iOS dependency manager. And CocoaPods supports both open source and closed source dependencies. So if you use CocoaPods for GitHub projects that are open source, you're usually pretty safe. But the problem is that CocoaPods allows any kind of web source, including unencrypted HTTP. So what you usually want to have is HTTPS or SSH. So as part of this project, I submitted multiple pull requests that would add a warning for the publisher as well as the user to say, hey, be careful, this pod transfers stuff unencryptedly, meaning that you can easily be hijacked. So again, if you use the latest version of CocoaPods and something's hosted on GitHub, you're pretty safe. But let's take a look at some of the SDKs that are not hosted and distributed through CocoaPods. All right, this is the fun part of the presentation. Localytics, for example, their docs page describes how to install the dependency. And the docs page is unencrypted. You can see this little question mark symbol. And again, this has been resolved after reporting the problem to them. So, and you might be thinking, well, I'm just looking at the docs, right? What can they do? They can replace the text maybe, right, or replace the logo. Well, if they can replace text, they can replace any link, any redirect, anything. So that means they can replace an HTTPS link with HTTP. Or they just use a very different URL. How do you know which one is the right one? Anybody can create an S3 bucket. So to verify this assumption I had, I set up a Raspberry Pi, and I took a look if I can replace all HTTPS redirects and URLs with HTTP. Again, this is called SSL stripping. So only using publicly available tools, I didn't have to reinvent the wheel. It took me about an hour to get this thing working. I set up my Raspberry Pi to intercept all traffic and replace every SDK download with a modified SDK, as you can see on the last line here on the screen. And so once the user downloads it and you extract the binary of localytics, you would see that I modified a plist file. And of course, I also added the trollface.jpg to the folder. So what are the requirements for this attack to work? Well, the attacker has to be in the same network as you are, and the download has to run through unencrypted HTTP. So you might think, well, OK, Localytics might be a smaller company. What about big companies? They can afford an SSL certificate, right? And yeah, you can see AWS has a green badge. Nothing to worry about. And also, your browser warns you about this thing called mixed content. So if you access a website and they include JavaScript code through HTTP, or if they include an HTTP-based image, you get a warning. You get a yellow triangle. So in this case, everything is green. But then you scroll down, and you move your mouse over the download button. And you will see they didn't specify the protocol. They just specified the host. So by default, browsers still to this day use unencrypted HTTP. So the really bad piece about this is if you click the download button, you don't get a warning. Because for the browser, this is fine, because it's a separate page. Different topic now, phishing. So about half a year ago, I published some privacy-related projects, one of which was about phishing pop-ups for the iPhone. So everyone here who uses an iPhone probably saw this dialog before. It would randomly appear and ask for your most important Apple password. And users are trained to just enter it all the time, every day, every week, whatever. So replicating this pop-up, you have no way as a user to distinguish between the two. So again, I published this about half a year ago. And then I thought, how difficult would it be to hijack other apps to steal passwords from the user for you and send it to your server? All right, so that's what I did. We have an empty iPhone app with just a map app rendered. And we now want to add a new feature to this application. So we now go ahead and Google for the AWS iOS SDK. And we open the official page here. And we come through Google, and Google automatically prefers HTTPS. We click on download. You see everything is green. We see the download starting. And we now then extract the file. And as you can see, there was not a single warning. There's nothing where you could have seen that this is potentially hijacked. And so this is my clean MacBook Pro. There's nothing installed, right? There's no firewall, no VPN, nothing. And we now drag and drop those frameworks into our project. That's how you install dependencies on iOS before CocoaPods. And we would now go ahead and require the library, because we need to load it to the runtime. And we don't even have to use the class. We just have to import it. And that is enough for the user, when they launch the app now, to see this iCloud phishing pop-up. And again, this is not the real pop-up. So as soon as you enter your password here, what happens is that you would see it in the log down there, and it could potentially be sent to any remote server without you knowing. And because networking on any platform really is not sandboxed, you can just send it to any server. So this doesn't sound too good. So to summarize, what are the requirements for an attack like this to work? It's actually really easy. You need any computer. It could be a Raspberry Pi. And the machine has to be in the same network as you are. And the download has to run through HTTP. And again, all the tools I used are publicly available and rather easy to use. So the previous example injected malicious code into the SDK. Now I was thinking, what's an even more interesting attack vector? Well, what if you attack the developer's machine, this MacBook right here? Because once you have access to that machine, you can access the keychain, API keys, any build secrets. You can record the developer's screen and send it to a remote server. Or you can install a new root SSL certificate to then intercept any encrypted traffic in the future. So I like this. So I was looking at the available SDKs and what you can do with that. So I found this little SDK, that one service that provides an SDK on their HTTPS encrypted docs page. And as you can already see, well, they provide a curl command. You should copy and paste that, and you pipe it over to SH. So that by itself is something you should never do. But also, they didn't specify HTTPS, even though they would technically support it. So I don't think I have to tell you that that's a terrible idea. But I was really excited again, so I thought, let's use that to, within a few seconds, enable remote SSH access and install a keylogger to be able to see any password and anything they enter. So I did that. Here's the result. We now copy-paste this command. And on the left side, you can see the user. That's the developer's machine. On the right side, you can see the attacker, the Raspberry Pi. And after a few seconds, you can already see the input being mirrored between the two screens, because we already have a keylogger installed that remotely pipes all the input the user is doing on the Raspberry Pi. So you can even see the Alt keys and Shift and all that stuff. And now that we have a keylogger installed, we will quickly find out the user's password. And once we have that, we can just SSH into the developer's machine and have full access to any files, any source files, any API secrets, and the user's keychain, and with that, any API tokens, or whatever we want. And so if we take a look at what the file now includes, you would see the malicious code is nicely marked. I always add code comments, so everybody knows where the malicious code is. So you can see that it's really just 20 lines of scripts that I took from this website that allows you to do that. So now you're thinking, Felix, how realistic is such an attack? This would never happen, right? And it never happened in the past. Well, even if you use a VPN, even if you're careful, it can happen. And those things happen all the time, really. So when it comes to Wi-Fis, you know, venues like this right now, they're a really good target. Just use the conference Wi-Fi. People install SDKs and NPM and cookabout's all the time. Same for conference hotels, same for airplanes, same for airports. Everywhere where you're in a Wi-Fi network or Ethernet network, really. And again, if you use a VPN, do you really trust your VPN provider? Same for the ISP. Those attacks did happen in the past. So again, I was analyzing the top 41 most used SDKs. And I excluded all the Facebook and Google SDKs because they used proper HTTPS with HST. So these are the most popular SDKs according to appsite.io. It's a website that analyzes SDK usage across apps. And so the scary piece was that I reported this issue to all the SDK providers, obviously. And I reported it half a year ago. This was a project I did in October, November. So one provider fixed it within 3 days, which is pretty good. Changing a link, right? 5 of them resolved it within a month, which is still fine. 2 needed 6 months to resolve it. They just fixed it right before this conference. They probably knew this was coming. And then 5 are still unresolved to this day, which is no good. And I just want to say this again. These are not small SDKs. This is not like a small indie company that someone dumps out code somewhere. These are the most used SDKs for the iOS platform. And so if you're using open source software, you're much less likely to be affected by those attacks, because people generally can look at the source code and you can see what's happening. But we're not only talking about person-in-the-middle attacks here, because there are so many realistic other attack vectors. So for example, an attacker might gain access to the SDK download servers. This happened to SDKs as well as Mac apps like Transmission. The company providing the SDK might just get compromised, because people know how many apps have this certain SDK installed. The local government forces the company to include backdoors, or the company providing the SDK is just evil and they don't care about GDPR regulations. So again, you are responsible for the binaries you ship. You're responsible for not breaking the user's trust, and you're responsible for following the GDPR regulations. So I started a crowdsourced list on these SDKs. And this is not a list for is this SDK safe? Because I was just describing one attack vector. And it's the most basic one, getting the SDK from them to your machine. It's a very basic requirement. But still, a lot of SDKs got it wrong. So you can check out the GitHub page, and you can also contribute. I want to set it up to be crowdsourced. So just to summarize, as a developer, it's our responsibility. We make sure to only ship code we trust. One of the easiest attack vectors and one of the most efficient attack vectors is through SDKs, because you can reach millions, hundreds of millions of devices through thousands of apps. So since this attack can be done with little to no trace, you will not easily be able to find out if you are affected by this. And so I encourage all of you to be careful with what libraries you include. Only include libraries you trust, and ideally they're also open source. Thank you. Let's see if our moderator is here. So we do have time for questions. I think I will check.
Wow, you ran out of stuff quite quickly, didn't you? Excellent. You said you had 40 minutes. What's going on? Was it too easy? Was it not enough? OK. First question by Anonymous, the hackers.
Can you tell us which SDKs are still affected by these issues?
How do you know that? Oh, you read it. OK, fair enough.
So I don't want to call them out here, because I don't want them to get mad at me. But we have this GitHub page. People can add it. The GitHub page describes how you can check it. And if you send me a Twitter DM with a nice text, I might be able to send you the list also.
Would you recommend conferences encrypt their Wi-Fi?
Yeah, there's no real solution. I think I mentioned very briefly only, even if the Wi-Fi is encrypted, you can still do all these attacks. Because through ARP spoofing, poisoning, you can still do all that. So even if it's encrypted, and that's what WeAreDevelopers does, so that's good. That makes a few things trickier. But with IPv6, it's even easier to do man-in-the-middle attacks in your local network. So there's really not much conferences can do. You have the responsibility on your machine to only allow HTTPS traffic, and that's what I did on my personal machine using certain tools. Like I use Little Snitch. It's a software that's being built here in Vienna. A Little Snitch, you can just disallow all of port 80, because port 80 shouldn't be allowed. So it's funny, because then some apps stop working, and you're like, oh yeah, I shouldn't be using this app then, or I should tell them. So I block port 80, except for the browser, just because the browser has its own mechanism. And if you Google for anything non-tech related, a lot of pages are still not encrypted.
What do you think about storing Wi-Fi passwords and storing them across devices as well? Because, for example, when you use something like a Pineapple, the attack proxy that basically simulates known Wi-Fi networks, creates them on the fly, you connect to them, and you don't even know that you're on connection. Do you think we should not store these passwords? But that's just not sensible, is it?
Yeah, I think it's impossible, because if you connect to a thing, it could be that you are aware of it, or it could be, as you said, like just the same name, same SSID. I really believe that we as developers should only use HTTPS, obviously, but then also we should protect our own machines by just disallowing everything unencrypted. Because then, if you connect to the Pineapple and it does something malicious, it does this person-in-the-middle attack, they cannot really do anything if everything is HTTPS encrypted. Because that's why you have the root SSL certificate on your local device, so you don't even have to connect to the internet.
Yeah. Google just announced that they're turning off the HTTPS as secure in Chrome.
Yeah.
Do you think it did more bad than good to give people the assumption that things are safe? Or what can we do to educate people?
Yeah, you're referring to the secure badge, right?
Yeah.
On the website. That's a good point, yeah. I also hope that I made it clear on my talk that the other SDKs are not secure, but they're just not affected by this attack. So I think the browser has the same problem, where it's like, yes, it's secure transfer, but it doesn't mean the website is secure. It's really tricky to educate people, for sure. And even developers are easy to be phished, and it happens all the time. I don't know if there's a good solution.
How will HTTP 2 change all that?
I have to say, I don't know. I didn't look into it.
OK.
Yeah.
Which SDKs are you using is one of the questions there.
Which SDKs am I using? Yes, so since I work on Fastlane and Fastlane CI, my stuff has mostly shifted over to Ruby. So because Fastlane is written in Ruby. And so we have quite some dependencies in the Ruby field. The good thing is in Ruby, all dependencies are open source by default, really. You just have to look at the license. So that makes it easier. And we also don't do full security audits on everything, obviously. We should probably, but it's just not feasible.
Well, in the NPM world, there are services like Sneak that actually go through your packages and end up malicious ones. Is there something in the SDK space for this as well?
Yeah, there's something built into GitHub now, which is really nice. So GitHub will now show you known security vulnerabilities on those SDKs. So that is really useful because everybody gets it for free. It's built in. So you would get a notification, hey, your project X depends on this library, and there is one known security vulnerability over there. So I think that's a really useful feature.
Okay, how to prevent attacks? That's a very open question. That's quite interesting. I think we don't...
Who asked the question? Can you talk a little more about
Milo?
In what context? Because I think my talk was pretty much about that. I hope so.
Okay, let's swiftly move on to what's your opinion of the Swift package manager?
Yes, it's an interesting project. I think there's a lot of politics involved. So Swift Package Manager is this project that Apple started about 3 or 4 years ago without pre-announcing it, so the CocoaPods team was surprised. And it's this half-baked dependency manager written in Swift that you cannot use yet, except for server-side Swift application, but nobody really uses Swift on the server yet because it's just so new. So it's kind of weird that Apple didn't fully focus on getting it up and running for iOS projects. But then again, if you get it running on iOS projects, you still have the problem that it will only work for Swift, while most iPhone apps are still written at least partly in Objective-C. So it's interesting why it takes so long, to be honest, because I think it's been 3 or 4 years now without a lot of movement.
In the web space, I work with Apple with the WebKit team a lot, and they're actually pretty good in sharing information and sharing security blacklists, these kind of things with people. Is there something like that in the iOS world as well? I'm not saying that you should name and shame them, but I just wonder if it's the same kind of approach.
Yeah, I think it's less common on the iOS field. I feel like on average, it's not as far ahead yet when it comes to security. That's why I'm talking about these topics, because animations are cool, 3D cubes and stuff. Nobody cares about security yet, I feel like. That's part of my mission. I want to change that to make people more aware.
And I mean, do you have any horror stories that you tell people that are big problematic, or is most of it when there was a security breach, it's basically just mentioned in a smaller group and not publicly available?
What do you mean by that? Could you tell more?
Well, do you, when it comes to the SDKs, you talked about the vulnerabilities. Are there any known exploits that have been affecting companies, or has it mostly been on the down low when something happened?
Yeah, I feel like the biggest one recently on the iOS side of things was the AF networking bug that was introduced. And the AF networking had a bug where it didn't fully verify the handshake. So every library that was using AF networking is the #1 networking library on iOS. So it was an easy attack. So it affected tens of thousands of apps. And the second piece that many of you iOS developers at least know is Xcode Ghost. So that was 2 years ago. And because China has this like standalone internet thingy, when they download new versions of Xcode, it has to go through the firewall. So it's really slow. So what happens is that there are companies hosting a cached version of Xcode inside China. So these companies got approached by whoever, advertising companies, government, nobody knows, to modify Xcode and provide that as a download. This would trigger a warning on the first time you launch Xcode. However, what do people do when they get a warning? It's like, yeah, there must be an error, so continue. So what happened is that every app that was compiled with Xcode Ghost was then modified to have additional analytics, like what device it is, what tabs the user does, and so on. And it affected huge apps, like I think it was WeChat and some others, that got affected by this attack.
Wow. Yeah, that's a problem when updates like Xcode are that big in like low connectivity countries that that's an opportunity for malicious caches to come in. Mm-hmm. Do you think that will be changed in the future? Is there any way to actually get the updates smaller or chunked?
Yeah, I don't think Apple's working on that because they assume everything's going to be faster. I do think it's Apple's responsibility to provide faster downloads in China and other countries. But I remember Visual Studio, that was about 10 years ago when Visual Studio just came out, the Visual Studio Express version. The head manager, his main vision was, this should be below, I don't know the number, let's say 50 megabytes. Express should be for people everywhere in the world, should be 50 megabytes, free for students, for everybody, and that's what they aimed for. I think Apple doesn't do that currently. Currently, Xcode is like 12 gigabytes.
Because most of the market is also outside these countries. Most of the market is in the Western world for iOS
Yeah,
apps.
everybody lives in San Francisco. So.
So are there any statistics about how often such attack happened, and also on other platforms like Node, NPM?
Yeah, I would argue that most of these attacks never, bubble up and nobody knows about them. I think most of them just happened and they stay quiet. So one thing, there was a really good blog post about 3 months ago that was about using an NPM module to harvest credit card data. I think probably a lot of you read that.
Well, this was a hypothetical example.
It wasn't
a real.
Everything was true. Yes.
Yeah.
So that apparently didn't happen, but it's very accurate on how it works. You start an open source project, you get more and more users, and then you slowly inject bad code in there. And then this whole thing on, for example, the simulator, you saw the pop-up on the iCloud phishing thing. You would think, oh, I would see that, so I wouldn't ship it, right? But then you can do things like, do I run on the simulator? If yes, don't show it. Only show it every 100th time. Check the location. All these things you can easily hide very secretly, and nobody will find you.
One huge thing in the NPM world is misspelling of packages, that actually people release malicious packages with misspelled names of very common packages. Is that something you find in the SDK iOS world as well?
I haven't heard of that, to be honest, but it sounds like what happened with domains back in the days also, and still, probably.
Nice.
Right?
Today you learn everything here. Do you think browsers should default all unprefixed links to HTTPS?
Yeah, that's interesting. From my noob perspective as a non-web and security engineer, yes, but I think there's a reason why it isn't. The problem, for sure, is that if you use HTTPS on the first request, you don't get a response because it doesn't respond to the SSL handshake. But the browser could handle that. So I don't know why it is, but I think there's a reason. But I don't know.
Well, of course, HTTPS used to be a problem, but now with like Let's Encrypt and other services, it's actually much more affordable.
Yes. And it's even free with Let's Encrypt. And Let's Encrypt is a big player when it comes to that.
What do you think of people using Google DNS and now Cloudflare's DNS as well, like the 8888 or 1111?
Yeah. So, I mean, I work at Google, so there's that. And then also, I think that the thing is that a lot of people think that if you use HTTPS or if you use a VPN, that the host name is not public. But the host name already tells a lot about your browser history. Think about it, like the host name is google.com, facebook.com, without the get parameters. You can always see that in every packet that is flying around, right? Unless you use something more sophisticated to encrypt the stuff. Meaning that if you access a website and it includes an image or a script from another website, this is all visible. So I feel like with DNS, you also just do host resolving, meaning it's the same information that's already floating around anyway.
With CDNs and other services where you actually distribute your load, do we even have a chance to see the domain as the main resource? Or because a lot of caching happens, especially in low latency countries, that we actually have injected CDN proxies in between, that might be a problem for these kind of scenarios?
Yes, I think it's the same risks. But I don't know too much about it. Again, I'm not a web developer. I don't even know why I get to talk here, to be honest.
Did Apple change anything so we can identify malicious pop-ups now?
Oh, not yet, but I'm sure iOS 12 or iOS 13 will have something. Apple's shipping cycle is a little, let's say, slow, because they only ship once a year, right? But it will be fixed. There was no public response from Apple, though.
Wow. OK. Is Alamo 4 in the group of the SDKs that have not resolved their security issues up to this day?
No, it's not. Alamo Fire also, I assume it's Alamo Fire. Alamo Fire is also open source on GitHub, so you're not affected by this. Because if it's GitHub, it uses HTTPS or SSH by default. Turns out some libraries defined the Git protocol, and the Git protocol by default is also unencrypted, which is really tricky to find out unless you look into the source code. So just this week, we also patched CocoaPods to warn about that also.
Yeah, Git just also released for hosted domains to have HTTPS encryption for if you host your content on GitHub itself.
Yes, they launched that for custom domains. They had it before for github.io domains.
Yeah. What do you think about the future of Ruby? Will it die out soon or even be used for new projects? That's a bit of a loaded question.
Yeah, I mean, I saw this graph recently about the number of RubyGems packages being published, and it went down slowly, the number of NPM packages. OK, so I was like, all right, I don't want to land on the street next year, so I started learning JavaScript. So I did that over the last, I don't know, half year. So my side projects are now built in TypeScript and Node just to learn something new.
Yeah, but I mean, the amount of packages does not necessarily mean the quality of the framework.
That's right.
Do you think the Ruby gems also went down because a lot of them died out or didn't get maintained anymore or were basically replaced by ones that everybody used?
I do feel like Ruby is a niche, and Ruby was highly popular in the iOS community just because CocoaPods, Matt Thompson's tools, Fastlane, and other tools were written in Ruby. I do believe that Ruby's community is not as active and as large. Like we write Fastlane CI in Ruby, we use Sinatra, and sometimes you run into issues that are like so obvious, and you think like, oh, that's interesting that it didn't get fixed yet.
When will Fastlane have better support for Android development? You know, those Google mobile phones.
Yes, I got one. I don't know. We're working on Fastlane CI now. So Fastlane, we maintain and we build new stuff, but it's not like an active effort. I mean, it works with Android tools, right? You can already use Gradle and stuff, but we're not going to actively build new features.
How is it to be the iOS person in the Google space? Is it like...
I'm not the only one. Turns out we have other iOS engineers, because there is a few apps like Google Maps and YouTube. It's actually its own ecosystem there. Yeah, it's definitely interesting because you do have Google, but also you have the best practices on the iOS platform. So you always have to find this balance. And what's more interesting for me is that I'm the open source person in my team, basically, because I really care about it. And I always tend to do things in the open. Like I'm the one who says, hey, why don't we have this meeting in the open so everybody can join? Why don't we put that design doc on GitHub so everybody can comment? So that's an interesting balance because you also want to come across as a unified voice with a plan and a vision, but also you do want to include outside people like non-Google employees early on to make sure you're going in the right direction.
That's why there's Edge for iOS, for example, as well.
Edge?
Yeah.
Oh, the browser, yeah.
How can we make sure that all SDKs solve the issues without breaking the apps already running it, without running in the problem?
Yeah, so the thing I described was only about downloading the SDK, so nothing would be broken. What I guess this question is referring to is if the API endpoint would change from HTTP to HTTPS, that in fact would break all the versions if you enforce it on the server. So that is called HSTS, if the server enforces that. And only very little number of hosts actually do that. It's quite tricky to set up, and then you would only allow HTTPS connections. But again, what I described here wouldn't break anything.
How does IPv6 make a difference for ARP poisoning?
Oh, I didn't look into that in particular, but that's feedback I got from the post from 2 people that said with IPv6, ARP poisoning is built in. I don't know how it works, but apparently it's even easier than how it works with IPv4. And so, assuming you don't want to do ARP poisoning, you can also do the same attack with what you already know with unencrypted Wi-Fi's. Unencrypted Wi-Fi's by default, you don't even have to do poisoning because everybody can read everybody's packets.
That used to be when we didn't have HTTP with browser add-ons like Firesheet, for example, back then. Good times. It was good fun to go to Starbucks.
And can you imagine that back then, Facebook and other companies, they were using the chat WebSocket connection, and they didn't use HTTPS encryption, and they sent the cookie through HTTP, and that was only, how many years ago? 6 years ago? It's so hard to imagine, because it's so easy to then take the cookie and do anything.
Yeah.
Nowadays, it's companies are a lot safer when it comes to that.
I like the ominous of that one. I always like that half these questions are just like, I know something, but I'm not going to tell you. Have you looked at all the SSL root certificates installed on your OS browser? Lots of interesting organizations and countries.
I didn't, no. I did take a look of how easy it is to install your own root certificate to then do anything. So that's basically when you use Child's web proxy to intercept traffic, you would install a fake root certificate on your machine to approve everything that goes through Child's web proxy. So the way it then would work is that you would get packets that are encrypted, you can decrypt them, and then you can re-sign them as yourself. So you're already approved. So that's why fake SSL certificates are dangerous. But operating systems make it very difficult to install it. You have to confirm like 3 times or something.
It's pretty interesting when you got Little Snitch running or Child's proxy or Fiddler. The amount of traffic that you see coming in and out, and a lot of, especially when it comes to ads, there's so many things that get unencrypted.
Yeah.
Back in the days, we also had the problem if you had an HTTP website that was including an HTTPS iframe and it had a backwards compatible meta tag, it got all the security problems of older browsers in the iframe as well.
Yeah.
So there's a lot of danger moments there. The third-party clients are really a tough thing to put into your service system to actually trust.
Yeah.
Does Fastlane work with something like NativeScript or React Native, or only with native code for iOS and Android?
Yeah, Fastlane works with anything as long as you have a project or you have a binary. So yes, it works. I know a lot of React Native. A lot of our users use React Native. I don't know about NativeScript. I haven't used it, but it will for sure work. Yes.
Okay, we reached the spaces or tabs question, so I think we're kind of done here, except for, as I said, why not both? Make it interesting. Will Fastlane incorporate security scanning for vulnerable SDKs similar to GitHub security alerts?
Yeah, I mean, it would be a new project. I don't think we're at the right spot. Like, I think GitHub is doing a good job with that. What we do have, what is not really similar but kind of related, is we have this tool called pre-scan that is part of Fastlane. So when you upload a binary, you have to go through app review. And app review feedback is really slow. It takes multiple days sometimes. So what we do is we have a list of predefined rules that we check for. So for example, if you mention Android in your app's description, you get rejected. Yeah, no Android. So we would show you a warning that says, hey, you got Android in the description. You're probably going to be rejected if you go ahead with this. So we basically pre-check your app to make sure that you're not wasting time.
Excellent question there. How to raise security awareness with software companies and PMs and POs?
Yeah, that's tricky. I think I would just passively aggressively send them articles about leaks. Because if you look at I'm not serious though. But there is a lot of, if you look at it, there's every single week, there's one major leak somewhere. And so, for example, I'm using MyFitnessPal. So MyFitnessPal just got leaked. And the Equinox things and all this stuff. Every week there is some leak going on because of the lack of end-to-end encryption. The only way to protect it is through end-to-end encryption. And it's tricky to convince your PMs. And what is PO even?
Purchase order? I don't know.
Oh, yeah. So I don't know. It's tricky. I feel like it's easier if somebody is a software engineer and they become a manager, but it's tricky sometimes.
I actually wrote a blog post just about this, what happens after being senior developer and getting into management, so that might be a help there, just to bring that in.
All right.
Anyways, we're out of time, so I thank you so much. Make sure all your SDKs are up to scratch and don't trust anything and anybody. I see you back after 15 minutes here. Let's have another break. Thank you very much.